Bhardwaj. I'm going to make a presentation on effectiveness of friction dampers using energy balance concept. In order to make earthquake resistant design, several methods have been proposed. One of these is providing passive dampers. So there are type of dampers: semi-active, active, hybrid, and passive dampers. So in the passive dampers also we have several type of dampers which have some disadvantages and advantages. And I have conducted a study on friction dampers. So the need for study as till now we look at the energy balance concept. Energy balance concept can be seen as a very promising concept in sense of energy dissipation efficiency of the friction damper can be evaluated more accurately than energy based design, such as Bhardwaj suggested one design that we can maximize the energy dissipated by friction damper, and other designs are also there which can be persuaded with, using this concept. Then performance seismic design also, like if you look at performance based seismic design, the ductile structures energy concept give more precise idea for the performance of the structure. Then my research objectives are like to mathematically model, analyze, and compare seismic response of moment resistant frame, brace frame, and friction damper frame to establish energy balance equations for all the three models. Then to study the effectiveness of friction damper using energy balance approach. Then to assess the effectiveness of friction damper for their using different number of stories. I have considered low rise and high rise, 5, 10, 15 and 20 story buildings models. These are equation of motion of the moment resisting frame, then from energy balance equation. So similar for friction damper frame. Here we look at the equation using the equation of motion. I have developed this equation. If you look at the previous equation, this equation has been proposed by Bhardwaj, energy balance concept. This concept has been suggested by the work done by various forces. According to this, I developed this equation. If you look at this is energy equation of motion of friction damper frame. Here it is inertial force, then damping force, then restoring force of column, and then restoring force from the friction damper. And this is the inertial force to ground motion. Now we look at the this term. If we apply here at this term, this inertial force. If we look at the work done by inertial force, it gives us kinetic energy. If we look at the damping force, it gives us energy dissipated by friction damper. If we look at the restoring force by columns, it gives us strain energy of the columns. Or in absence of the any external load, on the considered degree of freedom, the strain energy can be considered as strain potential energy also. Then the work done by friction damper can be considered as energy dissipated by friction damper, and then the work done by energy force to ground motion can be taken as input energy. So this is static loop obtained in the numerical study for 10-story building for Nova earthquake 1989. Now numerical studies assumption. I assume that two one-way frame for 5, 10, 15 and story building. The column and the floor were assumed as mass weightless, and all the mass was assumed lumped at two floors, two ends of the floors. Then sway at each floor has been considered as only degree of freedom of each story. Then no external force is acting other than the earthquake. Then earthquake ground motion is assumed acting in direction parallel to the plane of the structure. It is to be. Then the effect of soil structure induction was ignored. And these are the properties of the earthquake. I I considered 3 aspects. Then this is a validation part which shows that the results were very well in accordance. This is for numerical study, then this is for finality method. Then we look at this. This is comparison for 10 story, moment resisting frame, base frame, friction damped frame, which shows that the friction damped frame control the response of the structure very well. Here also. And this is energy distribution for friction damped frame for 10 story building and Imperial Valley earthquake. Which shows here we can see the energy. This is input energy. This is energy dissipated by friction damper, and this is energy dissipated by damping. In case if friction damper is not there, whole input energy would have to be dissipated by structural damping only. But if we provide friction damper, so almost 80% of the energy is being dissipated by the friction damper. This is low operator earthquake. Again, say 10 story building, and this is for north earthquake. Here we can see the comparison of maximum top floor displacement for Imperial Valley earthquake. The graphs I have put here only for Imperial Valley earthquake. So this is for base shear. Again, friction damper is showing the least base shear. Then this is for top floor acceleration. Friction damper frame is experiencing the least top floor acceleration. And this is for maximum input energy, total input energy, and energy dissipated by in structural damping, or we can say structural damping energy demand is minimum for friction damper. Then again, this is maximum potential energy. Again, the demand is minimum, and maximum kinetic energy. Again, the demand is minimum for friction damper. And this is the variation of structural energy dissipated by friction damper for different number of stories. Now, the conclusions. Now, we can observe here that friction damper reduces the displacement response significantly. Another is friction damper frame experience least acceleration compared to moment resisting frame and brace frame. Next is friction damper frame attracts significantly lesser input energy than moment resisting frame, but if we look at the brace frame, it is almost equal. But the superiority of friction damper frame can be justified in terms of base shear. Base shear is much lesser for the friction damper frame. Then structural damping energy demand is also very less. Then maximum potential energy, maximum kinetic energy is also very less. Then future scope of the work, optimization of the friction damper can be done by strategy proposed by Bhardwaj. That Bhardwaj suggested that energy dissipated by friction damper should be maximized for any structure. Then, considering material non-linearity, static energy demand can be estimated, and performing a seismic design approach can be applied there. And then multi-way three-dimensional structures can be analyzed, and effect of higher force on the input energy can also